We are all pretty familiar with our solar system. 99.86% of the mass of the solar system is the Sun. The rest are the rocky planets, the gas giant planets, dwarf planets, moons, and other minor bodies like asteroids and comets. We teach kids about these places in elementary school, but this doesn't mean we know everything about our solar system. Could there be more to our solar system that we don't know about yet? This question draws our attention to the outer reaches of the solar system. 30 times farther away from the Sun than the Earth lies Neptune. We have started to learn that there is a lot more to the space beyond Neptune than just the lovable Pluto. Countless objects have been found beyond the orbit of Neptune. We call them trans-Neptunian objects, or TNOs. Our story takes place out here. Most TNOs orbit in a belt of icy objects called the Kuiper Belt. As we discovered more trans-Neptunian objects, we noticed a few that had some peculiar orbits, including the minor planet Sedna. Many of these objects have large elliptical orbits. This isn't that strange. The weird part is that for a few of these TNOs, the place where their orbits come closest to the Sun, or perihelion, seem to be generally clustered together. It would be natural to expect that these would all be distributed evenly in all directions, not all clustered like this. And while the main planets and most solar system objects generally lie on the same plane in space, many of these TNOs are also inclined to this plane drastically. So why does this happen? One of the more popular ideas, initially proposed by Michael Brown and Konstantin Batygin in 2016, is that a planet beyond Neptune may have gravitationally nudged them into these orbits. To explore this idea, they simulated many imaginary versions of our solar system in a computer. For each simulation, they tried different possibilities for the size, distance, and orbit of a hypothetical Planet 9 in the outer solar system. They found that their simulations created this unusual clustered pattern if the solar system included a medium-mass planet, bigger than Earth but smaller than Uranus, way out past Neptune and Pluto. Since the initial proposal of this idea, more TNOs have been found that fit the pattern, which has required some refinements to the size and orbit of Planet 9. The more TNOs we discover, the more this idea can be updated and tested. The current understanding of Planet 9 places it very far from the Sun. At its closest point, it would be nearly 10 times farther from the Sun than Neptune, and its elongated orbit would bring it nearly 45 times farther away. At this distance, it would take over 18,000 years to orbit the Sun. This long ago, humans were still figuring out stone tools. While this is a fascinating idea, it really is still just a hypothesis. There isn't enough evidence to demonstrate that Planet 9 is actually out there, so let's not get carried away. While we can still enjoy the thought of Planet 9 existing, we should hold off until the evidence is more conclusive. And finding that evidence isn't an easy task with our current limitations. We're already pushing our telescopes to their extremes to find TNOs this far out, and a Planet 9 would be much further still. Planet 9 isn't the only explanation for the peculiar TNO orbits. There is still a lot about the solar system that we don't know about. It is likely that this could simply be a coincidence. With potentially billions of objects beyond Neptune, we might have just noticed some outliers in an interesting position. When it comes to detecting TNOs, we typically can only find them when they are near perihelion. This clustering could simply be because we have only been observing them for a relatively short period compared to their long orbits. Another explanation is that instead of a distant planet, there may be a smallish black hole orbiting in the outer solar system, which is responsible for the gravitational nudges. It may seem a little outlandish, as the existence of these small primordial black holes is still hypothetical. We've never before found a black hole this small, or that close to our solar system. However, the black hole explanation fits the facts currently just as well as the planet explanation. So it's not fair to dismiss it until we know more. For now, we will just have to keep looking. It's like trying to do a jigsaw puzzle without looking at the box, and we've only put together a little corner. Each time we place the next piece, we get a little bit more of the picture, and we see the solved pieces in a new light. It might be a long time until the puzzle is complete enough to be sure whether Planet 9 is truly out there or not, but that isn't stopping us from looking. While we can be hopeful there is a distant, strange planet out there, we shouldn't hold our breath. Maybe just cross our fingers. Thank you for joining me, and please check out our other Dome from Home programs.